I'm working for the Physical Crisis Management Assistance team for the California School Information Services. And what we do is we operate a statewide system that collects, counts, and reports student-level demographic, program, enrollment, dropout, lost kind of transfer student data to the Department of Education so that they can inform decision-making for financial decisions. They can inform through public websites parents about the rankings for schools. So we're in the process of collecting student-level data in its raw format from educational institutions, mainly California K-12 districts within the state and charter schools within the state. All those entities are required to submit us data. And we counted, collected, counted, produce reports and extracts from our system that we ship over to the Department of Ed. That's kind of what we're doing. Kind of a little bit of a review here. So in the next slide, I'll talk a little bit more about what we do. And then here we have design concepts, enterprise design patterns, inversion of control, little dependency injection, and inversion of control the same. And then we'll go into some examples. So at the beginning, I'll just kind of set the framework of discussion, and then I'll try and give you guys some examples of what we're doing. So what does CSIS do? Currently, we're assisting the LEAs, or the local education agencies, which are really your K-12 districts within the state, to electronically transmit their enrollment dropout kind of data to the California Department of Ed. Prior to 2000, all of this data was done on paper, and some was done through a raw number input into a CDE data system, but the schools had a lot more control over what they could do with that data at that time. So our system is more, it holds them to a more accountable standard, and they can't like invent students to make sure they can get another teacher and stuff. We also do records transfer. It's the second bullet, is records transfer between local education agencies and post-secondary. So K-12 to K-12 and K-12 to all of the California Community College and really any post-secondary institution that's out there. They can use our system to electronically transmit that data. We also do a lot of knowledge sharing and training sessions for the K-12 districts to bring their education technologists up to speed on what data is, how to report it, how to deal with it. So that next year when they submit us data, they'll do it better than they did it this year. So that's kind of this building capacity and best practices training that we do. All right, so one of the things, before I jump into this, one of the things that we have is we have a J2EE WebLogic backended with SQL Server 2005 enterprise application that handles this collection and reporting piece. To give an idea of scale, number of currently active students in the state, about 7 million. Number of students in the database is around 10 to 15 million. And when you take that many students and then count their classes and their ethnicities and their other stuff, we're talking with tables in upwards of 50 to 60 million records. So it's not a small data system. So one of the things in that it was designed in late 1999, early 2000, it went live in 2001, and it went live as a J2EE application. J2EE was a baby then. So there's a lot of things that we've learned over the last 8 years since it went live, in what and how J2EE applications are working today, and how to go through this change process. So one of the things that we're going to talk about is designing for change to minimize major redesign in your system. Obviously, in a system that we're working on today, 7 years later, we've done some major redesigns because things that we're doing today weren't thought about when they originally wrote the system. So thinking about how to build a system that's flexible enough so that you don't have to do these large changes in the future. We're going to talk a little bit about programming to interfaces versus the implementation. A little excerpt from the Gang of Four book. This is a concept that's critical, especially in Java, to make sure that you're programming to the protocol or the interface that your objects use. When you're talking about a collection of data like a list, right? You can have an array list or a linked list. The calling code that's using that data, it can refer to it as an array list, or it can refer to it as a list. And being able to just refer to it as a list allows you to swap out that implementation later if you find out you really needed a linked list or a duly linked list, right? So certainly ran into that many times. We're going to talk about coupling and cohesion in a minute. And I wasn't originally going to talk about coupling, but I thought that this to a design meeting with IBM for a new system that we're going to take over in 2011. And in this meeting, we're subject matter experts, and we're not designing or writing the application. So we don't have that much say, but we're doing the code reviews for them. And I got to look at their system and saw that they're very, very highly coupled and very, very non-cohesive in their system. So we'll talk about what that means and why it's really important. So coupling is the degree to which a program relies on each one of the other modules in the system. What you're going to hear a lot is that low coupling is desirable, not referring to the inner workings of another object or calling an object that has public methods on it is where you want to be. You don't want to be updating the actual variables inside those objects, right? Or even when you're sharing objects, you want to be really concerned about how you're sharing those objects. So we're going to talk about the different types of coupling. Let's run through this real quick. We have content, common, external, and control coupling. These are your lower, or your higher rankings of coupling. These are the ones where you're going to try and stay away from on this slide. So content coupling is where one module is going to really rely on those inner workings. For another module, they're sharing global data, right? If you change that global data, you may break one or both of those. External coupling, so they're on a communication protocol or the interface, and as you move down to the lower coupling elements, they start to be more ones you're going to have in your system over time. And the coupling measure of the system is really one we're going to look at the overall holistic look at the system and say, of course you're going to have some of these higher coupled pieces, but overall the stuff that's going to be really prone to change and isn't deep in your architecture will be more and more loosely coupled. You have the stamp data structure, or stamp coupling, where you have a data structure that in order to get it back to whoever needed it, you're going to have two different modules update that same data structure, and that's where you're going to have those breakages if you change that data structure that it's sharing. The data coupling is, we're going to have this module sharing through parameters, and this is really in the cert system, this is really where we are. Message coupling, not as much. This is one that we've really sought to attain in our software. It's kind of the concept of coupling and how to break those up. Let's talk a little bit about cohesion. And cohesion is, if you have an object, you have the different methods that you can put on that object. So the measure of how strongly or high or low, I think, are the terms that we're going to use to talk about cohesion. High cohesion or low, yeah. So to have really highly cohesive code, you want to have, for an example, if you're having a data access object that searches for students, that's going to be a highly cohesive module in your system, because everything in it is going to deal just with that student data. It's that core data set that deals with a student. You don't have an object out there that's your DAO for the system, so that you're going through that object every time you need to get to the database. So there's a breakdown to this, that ordinal measure. So you're going to start at the worst and go to the highest, with high cohesion being the best. So coincidental, coupling, logical, temporal, and procedure. Again, this first slide being the ones that you're going to try and stay away from. I think when I got done with the IBM meeting, I walked away saying they're pretty much only doing logical cohesion in their application. It freaked me out, and luckily we have service level agreements with them so that we can enforce that their software be maintainable before we get it. So mainly, they had all their database I/O in the same routine. And I would have liked to have seen that broken out a little more. So They're temporal, where they're grouped by when they're processed in the system, procedural, then they're grouped by a sequence in the system, and communicational, sequential, and functional cohesion. This is where we are in our cert system after refactoring it over the years. We've managed to get it up to the sequential or the functional cohesion. We do have a lot of batch jobs that go step by step in the system, so we are in this sequential model, but also in the functional cohesion where we're able to say, this one piece really just does the data access or the business logic around a student. Okay, so here we go. High cohesion is desirable, functional cohesion as much as possible, and communication or sequential if functional is not an option, right? So that's just kind of some guidelines. And again, these are the guidelines that we're using when we're looking at major refactors in our system, major changes or change requests that have come in that we need to implement. So keeping that in mind. Okay, so I'm going to talk a little bit about some design patterns today. So really common design patterns that are all over the place in our system are the transfer object, data transfer object, the data access pattern, and the factory method. These, I'm going to go through examples of these and then hopefully get an opportunity to do a demo with how we're using them in our system. So what's a DTO? It's a data transfer object. It's an object that basically represents some either entity or module in your system. A lot of times you'll see a DTO is bound to a screen. So you have a screen that you need to present a set of data on. When the user clicks and clicks a button on that screen, the system needs to process that request, potentially go all the way to the database, do some business logic, do something with the data, calculate some stuff, and ultimately return it back to the screen. So one of the things that we're going to do is make sure that it's a serializable, marshallable object, right? And what that means is an object that we're able to put on the wire. We're able to send it over the internet, and we can put it on the wire, we can get it back off the wire, and it's the same object when we get it back on. We're going to do those in binary or text-based serializations. We're doing them in certs as a binary. And so why are we using them? It allows us to do smaller method signatures. So we're doing, when you're coming out of a button click or an on click, you're going to go up to your business layer. You're going to say, hey, I need to process this request and go to the database. It's going to do that business logic. It's going to package it up in a DTO, and it's going to go across the wire once. So every time we go across that wire, we're introducing more latency in the response time for the screens in the application. So it's really critical to minimize that. That's the one return call also. So the smaller method signature is more along the lines of you can call an object with just one thing instead of saying I need to search by name and by social security number, and you have this big long method call where you could just have a DTO that contains the data for that object. So the one return value, obviously at least in Java we're bound to one return value. Best practice is to only return one thing. So if you need to return it, you're going to package it up in a DTO to get it out of that business layer. And then we're going to have less calls to remote resources, which is going to minimize the impact of having to serialize those objects and help improve their responsiveness. So really simple example. The serial version UID is part of the marshalling portion of in Java, so not as critical in other languages probably. But the message and the data are just two private variables that are in there. And then we just have the accessor, mutator, getter, and setter methods for it. So you can see if you had a student DTO, it would have all the stuff you need on the student, maybe a list of their enrollments, maybe a list of the programs that they're in, or ethnicities, or birth dates, because they do have more than one birth date sometimes. So you're going to package them up in that so that you can go to the database and go through the business layer and get all this data back to the front end in one object. So we've talked a lot about how to get to the database, so I'm going to talk about data access. So what's a data access object? So we're saying a data access object is one that's going to encapsulate the work of getting data out of a database. And I'm saying database here, but I'll give you an example. We have a the records transfer system that I mentioned. And we had had an older records transfer module, and we just partnered with the National Transcript Center to provide a newer records transfer module for our system. And by partnering with National Transcript Center, we got a brand new application for the users, written in a newer architecture. It is also J2EE. But when they designed that application, they designed it with a DAO layer, or a data layer in their application. Or you'll see here, data tier. We kind of have a data tier that's broken out by the actual data and the data processing. So that's kind of the layer approach, let's say that again. So what they did is by using the DAOs, we had a requirement in the project to say, we really want your system, but you're located in Texas. And we're not going to allow you to ship all of our student-level data and store it in a data center in Texas. So we needed a way for them to keep that data here. And it turned out that there was only a small set of data that they needed to keep here. And they were able to produce a build of their application by rewriting a small set of their DAOs to do XML-based access. And we now store that core set of data on a remote server in our data center in California. And they're able to open those resources, parse them, query them, and return results back over a secure connection from Texas and California. So that way that core set of data stays with us. A little bit of a political decision to keep it in California, but it's nice to have your hands on that data when you get the chance. So that's one of the reasons why that's really good. And one of the nice parts about it is this transparency. So why are you going to use it? You're going to use it because the objects that are calling the data, or that need the data, don't really need to know about how to get it. So a business object can use the DAO without knowing anything about the details about how to retrieve or process data from that resource. So your business object or the code behind or whatever model you're using in your design, not coupling that logic of how to open a database connection, query for a result set, get the result set back, process the result set, and then present the user back the data. By encapsulating it here in the data access object, this business layer won't have to change when you decide to sell your application to California and they want you to store the data in XML on a remote server. So that's why we're using the data access layer. It's also, and I already talked about it, but for the migration, right? They were able to easily port that build of their application so that one core set of those DAOs are available as remote resources. It really reduces your code complexity, right? You're not going to have the opening of connection strings, the parsing of results, all mixed up in your business layer. One of the requirements that I put on the development team at CSIS, you need to be able to read a method on one screen. Granted, they all have 24-inch screens, but you still need to be able to read it on one screen without paging. So if they haven't decomposed that enough into something that I can understand by looking at the method signature and the return value and the logical name of the method, it's probably too complex for somebody to come along later and support. Sometimes, there's always going to be an exception, but a lot of times you can break that out and refactor it into helper methods and other stuff. But this really takes that portion out that you can say in your business layer, I want to query for a list of students, create a new DAO, the DAO will ask the database for that list of students, package it up in a list, and then the business object can just operate on that list data structure. It doesn't need to operate on a Microsoft SQL bound result set or an Oracle result set, right? It doesn't have any. It's the whole portability thing. So that's when we have the DAO. And DAOs for J2EE, it's kind of interesting that I'm working on a J2EE system and I'm really pushing the DAO thing. We don't really use entity beans in our system. We have some really ancient ones, but most of that we've refactored out because we're running EJB2, and we really like entity beans in EJB2. It really got along with my thinking, right? So just a quick class diagram. You can see the business object is going to use the data access object. It's going to encapsulate that data source. The data access object is going to create this transfer object and return it back eventually to the business object. So that's kind of how that breakdown works. And the nice part here is, again, this guy does know about the data access object, but it has no idea how to get the data. It just knows it needs to ask for it. Another thing that allows me to do in development of our larger projects is I can assign the business object and the data access object to different developers and really streamline that development so that they're able to just complete one portion of that. And we'll talk about how to do that when one object isn't available in a little bit. So a sequence diagram for the DAO. You can see the business object is going to create a DAO. It's going to ask it for the data. DAO is going to create the transfer object. It's going to return this transfer object. And then the business object is probably going to set some data on it. And it's going to do some logic with that DTO, the transfer object. And then it'll manipulate it. And then whatever the business object, whoever called it, will get the results of that. So that's the breakdown there and the sequence of events. Okay. Give it a chance to talk about the factory method. So we talked about DAOs and DTOs. Now we're going to talk about factory method. So what is a factory? A factory is anything that creates objects, right? In our system, we really have a factory. The main purpose of our factory is to produce DAOs. That's kind of why I'm talking about DAOs, DTOs, and factory today, so I can get to the example later and show how that breakdown works. So why use a factory? We're going to use a factory here because it's going to allow us to have some loose coupling when we get into the next couple slides and talk about dependency injection. It allows us to get those dependencies in. It's going to help us in code refactoring, and it's definitely going to help us in maintenance. Now, the factory method, once it's written, it's really easy to use. It's not the easiest thing to write, although we're going to talk about the Spring framework in a little bit, which really makes that easy. But being able to just ask the factory for the data access objects and not worrying about their implementation at that level is really going to help us break those strong couples and really be able to change the system easily in the future. If we need to change the implementation of an object that's returned from a factory, we just change the implementation. We don't have to worry about any of the code that was calling it. And for those familiar with Java, that's the new operator we're really staying away from. Right? We're not calling a new every time we want a database object. We're going to ask the factory to do that for us. And that's going to help us not have to know in our calling code what concrete type that object is. And being able to get away from those concrete types and just program to that interface is what's going to make our code more maintainable in the future. So a little class diagram, the product and the creator and the concrete creator. So the creator, or the concrete creator, is going to use the creator method to create a concrete product, right? It's going to return that concrete product, but the code that's going to rely on this factory method is really only going to ever deal with the product, right? So if I have a DAO, I've defined a DAO interface. So in a little bit, we'll talk about the example DAO. And that's, the example DAO says, you're going to have two methods. And you can call me with these two methods. No implementation, right? It's kind of like a header file or a protocol. It's also going to then, somebody's going to be responsible to write the implementation for that DAO. So you're going to have that example DAO, JDBC impl, or XML implementation. When your calling code is referring to only product instances, the factory can return it whatever type of concrete product. But the calling code doesn't have to worry about those. So, okay, so that was the factory method. So we'll talk also about, now we're going to talk about dependency injection and inversion of control. Some really big words. And even in my own shop, we have 5 full-time Java programmers and 3 full-time database developers. Probably the only one who knows about this concept with these terms. They all know what the work is that they're doing and how it works, but I don't think they've ever really known the dependency injection portion. They'll get this training tomorrow, so I have to give it again. So the dependency injection. So big definition straight from Wikipedia. Essentially, I can use the DAO example. You have a database object that needs to work on some database. So it has a dependency. That DAO can't query anything unless it knows where the database is, how to log in, what type it is, what drivers to use. It needs to know all of that before it can do a query. Well, if I code that in one DAO, even if I code it in the base DAO, that's bound to a build in our software. What we're going to do is we're going to break that coding into a framework that's easily injectable into the system, and that's going to allow us to have runtime dependencies. So we're going to be able to compile this code, link the code, and have it ready to run. And the system still has no idea, except for the configuration area, where the database is, what it is, how to query it, and how to log in and stuff. So I won't read you guys the definition, but there's really three types of dependency injection. You have interface injection. So you have your business layer, or whatever layer you're using it in, is referring only to the interfaces of the objects. It's not referring to the concrete objects. By doing that and using some method, in our example later we'll use the factory method, we can change the implementation at runtime for the business object, or for whatever's referring to this interface. We can change that implementation at runtime. Second type is going to be setter injection, which is what the Spring framework is going to use. We'll see that in a minute. And setter injection is what it's allowing us to do, is you have these objects, and the Java beans are really perfectly designed for this because you define your properties and you define all of the getters and setters, or accessors and mutators. Those are the methods that you're going to call instead of referring to the private instance variables, right? Because you're not going to be able to get to them. So by calling the setter methods, we'll be able to set values on those objects. And like I said, that's going to be how the Spring framework in the example that I show you is going to use. And constructor injection, I haven't done anything with constructor injection. Some different frameworks use it primarily. But we've done, at CSIS, we've done our own custom implementation of the setter injection. We've also done the Spring framework implementation of the setter injection, and also the type 1 interface injection using the factory method. So I've said Spring framework a couple times. Anybody who's not familiar with Spring framework and the concept of frameworks, this is a publicly available open source framework. It's written in the Java language. It's also mostly been ported to .NET. I'm not sure about any other ports that are out there. But this is their excerpt from their sales page. It's the most complete. Right? I don't really know that it's the most complete, but it is what we're using. And it's going to allow us to have this auto wiring of the dependencies in. It's going to help us have the loose coupling. And it's really, for us, talked a lot about how it's important for maintenance and long-term to break those dependencies, or to build your really easily maintainable code. What this is really allowing us to do at certs is testing and isolation. We're able, using the Spring framework and using the factory method, to isolate modules that would ordinarily be dependent upon each other and test them as one unit. And that really, really helps our quality, and it really, really helps our efficiency in development. So I'll go ahead and I'm going to go through, in PowerPoint, the Spring multi-layer application example. And then I'll try and show the demo, if we have luck today, on dependency injection for unit testing. Okay, so some implementation. Let's stand in the room and show you a pointer. Okay, so here's an example factory. This happens to be a really slimmed down version of our factory. We have some other stuff in it. Actually, in this, we are missing all the include statements up above. We have our class declaration. It's factory. All this stuff is there for, these two are here just for reference. We have a beanref context XML file and a DAO application context file. We have those defined as public constants on this, so they can be referred to by other classes, but this class really, this really is the whole implementation of our factory, because we're utilizing the Spring framework. We have declared the factory constructor as a private method, which requires us to always access this as a static factory. So there'll never be an instance of the factory type in our application. We don't want to have multiple instances at a given time, mainly because this factory allows us to choose between prototyped object, which is essentially calling a new, or a singleton object. That you want the factory to always hand out the same instance of that object, regardless. So for our DAOs, we're always producing prototyped objects. It has one, makes a copy of it, and hands it out. Different memory space. It's like calling new. And then the singletons are going to be the ones, we have some object factories that use the singleton method to hand out things that are like utility functions that we wanted to be able to swap in. Like we have a file transfer adapter interface in our system, and we want to be able to swap out the implementation behind that so that the calling code doesn't have to know how to send a file using secure FTP versus how to send it over HTTPS. The factory is going to drop in that dependency at runtime. The configuration of those elements are done through the configuration files also. And then we can have code that knows how to send files. It says, hey, I know when it's time to send a file, I'm going to call send file. But it's going to ask the factory for the file transfer adapter first, and depending on how or why it's sending it, the factory will return back the right type of object to send it over FTP or HTTPS, depending on who the consumer is. So in the code here, we see this produce method. This is the main object here. The main method we're always going to be calling is factory produce. And we're going to pass in the name. Say, hey, factory, I need a DAO. And in our examples later, it's going to be the example DAO. So little safety checking with the null. This right here is you'll get this right off the Spring website if you were interested. This is how you make the Spring factory. We're saying object factory, and that's going to be referred to in our XML in a minute. And we're saying object factory, return us a bean with the name that we passed in. So that's how we're going to get an object back in the factory. So I'm going to give you two configuration files and try and explain the difference between them. We have an in-container configuration and an out-of-container configuration. So what's the difference? I've been talking about J2EE programming. You notice in J2EE, we're going to always have in the Java naming directory, I want to say Java naming directory interface, JNDI, we have a tree, or the data that's stored in this application server of where all the database are. What are the pools? What are their connection strings? How many connections can be on? What are the usernames? We're going to ask that JNDI tree for that information. And in this example, it happens to be running locally, and it's on port 8031. You see up here, this is the JNDI template. The JNDI template was provided by Spring Framework. It allows us to auto-wire in those connection resources for a DAO. So I've gone ahead and also configured a pool here. This pool is using the object factory bean. Right here you see the JNDI template and the JNDI name. In my example, this is example pool. In my configuration files for WebLogic, I would have set up example pool as a pool connecting to some database. This right here, these two property settings here, are going to allow this bean, example pool, to have their dependencies injected by looking them up in the JNDI template. So that's kind of, now it's a lot in that slide because it's dealing with JNDI. The next example is going to be the out-of-container configuration, which I think is a little more straightforward and we'll use for the rest of today. So example DAO is our actual class. Right? Here's our concrete class. It's example DAO, JDBC impl. The JDBC impl is a naming standard that we've implemented to say this is a JDBC implementation of a data access object. We're going to refer to it as example DAO on our implementation, or actually our interface. We're going to define example DAO lookup name, so we'll always know how to get it. And then we have example pool. This example pool refers back up to here, which also then refers to JNDI template, which refers back up to here, which is going to get all those resources built into the object by Spring. So when I ask on the previous slide, when I say produce example DAO, it's going to go look in the object factory and get me a bean with that name. And I don't have the whole XML file here. I can show it, time permits. That will show at the top of this XML document. It's actually called object factory. So we'll go into the out-of-container configuration. It's a little bigger file. Now we're talking about, really for out-of-container, we're talking about running this application code, which was written for a J2E server, without the server running. Server takes a long time to start up. There's server resources that are needed. It takes a lot larger of a box to run. And we do have the need to run some batch jobs out of container without the J2EE server running. And certainly, because we're not using any container managed persistence and we're not using any container managed transactions, we're able to break that boundary here and use out of container also. And out of container is partially how we're doing unit testing on the database level without the server running. You can do this using Cactus. If you want to run it in container, Cactus is another framework that will allow you to do unit testing outside. So if you see down here at the bottom, we have example DAO. It's the same line from the before XML file. But now you can see here's how our example pool is a data source pool. It's going to use this driver here. Not that driver. It's going to use this. This is in Hydra JDBC standard that we're going to use. Going to use this JDTS driver, which I have on the class path, and here's our connection string that you would see in Java normally if this was written in the DAO class. Username and password, and then your pool, username and password, and how many of these connections you're going to allow to occur. So that's kind of the connection management piece. But ultimately, what Spring is going to do is going to say, hey, you asked me for example DAO. I'll create one of these implementation objects, and I'm going to inject into that example DAO this data source, right? So now inside of this class, and I'll show it here. Well, I don't know if I'm going to have that slide. We can look at it in the. Here we go. So you can see in the example DAO, there's no connection string information, right? So now I guess I'll come back to that. So, but this is going to auto-wire in the example DAO, the data source, so we don't have to have that configuration. This is really the one place for our configuration for all those, how to connect, where to connect, how to log in. 2 files. In container, it's stored on the class path by putting it in a jar inside of the enterprise application. And out of container, it's on the class path by being on the class path just in a folder that our IDE knows to look in that folder before it looks in the other one. And it picks up this as its settings. Okay. So we'll just kind of try and talk through an example use scenario. We have an example business object here. It's going to query for, this is just a really simple example. We're going to look for an example by name here. We're going to pass in the name that we're going to look for, and we're going to expect back an example DTO. In here you can see we're calling factory.produce example DAO. Right? So back to the other file. Here's that example DAO string. So when it asks the Spring Factory for it, it's coming in here, and that's where it's figuring out what object to produce. So it's asking for that example DAO. We're going to cast it back, even though Spring produced one you saw it in the previous file, the full concrete type. We're going to cast it back to the interface here. We're only going to refer to it as the interface type. So that's why we define the variable as example DAO. It's a naming standard to do the lower camel case for the actual instance variable, but we're always going to refer to it as the interface type. And that will allow us, if we change the implementation in that factory configuration file here to XML implementation, your calling code will always be able to handle that. Even if it's XML, it knows it can call this method as you implement it in your XML implementation also. So here we're going to find the example by name. We're going to get back a DTO. We're going to do a little logic on it and say, if the name that comes back in the DTO is equal to hello world, then we're going to call setName to the hello world business object. I just wanted to do something with that data, show that we're setting stuff on the DTO here. I couldn't get a real code example to fit on the PowerPoint, and I wanted to make sure I had code on the PowerPoints in case the demo didn't work. So here we go there. So I've talked a lot about the interface. This is really what the interface looks like. It just says, on the example DAO, anything that implements this interface is required to implement a find example by name and a find example by session ID method, right? So our example DAO JDBC sample, when it does the implementation, has to implement both of these methods in order to say that it implements that interface, and that's why we can cast it back to this type instead of the concrete type and refer to it because they're required. Now, the example DAO JDBC sample could have like 15 more public methods on it. By coding only to the interface, we'll only ever be able to use those 2. So there's the actual implementation. Won't spend too much time here, but you can see We have an example DAO JDBC impl. It's extending the JDBC DAO support. That's a Spring piece that we're going to extend. That's how we're going to be able to auto-wire in those dependencies. And it's going to implement that interface. So that's why we've implemented a find example by name and a find example by session ID. Now, if you look here, we don't have any connection string information. This is where we're asking the JDBC template to just query for this object, passing it this SQL string that we said select top one, for example, where name equals name. Really bad, don't do this in your code, but I didn't want to have to do a prepared statement. You should parameterize your queries to avoid SQL injection, but just to get it on one line there. So example row mappers down here, it's going to map this result set that came down from the database for a column with the word name as a column header. You can do that by position. It's going to set that name on the DTO and return it, which is this return statement is also going to cast that return down there to an example DTO, which is going to allow our business object now to get that DTO back. And I show the implementation for the session ID, but I said we're not really going to call that here. Okay, so 3 more minutes. So we got unit testing. So why is this important for me? I want to be able to use dependency injection to isolate that code for unit testing. So we have dependency injections and isolate code. How do we do it, right? So we have a class. In this case, we're going to have our business object that's going to be under test, and it's got a bunch of collaborators. Now, when you're talking about collaborators, you're talking about things that that class calls. So if it calls another object, you're going to say, business object is calling the DAO. DAO is a collaborator. Right? Well, when we're testing this class, I really don't care how the DAO works. It might not even be written yet. And I shouldn't have to care how the DAO works. It should work. So when I write my unit test, I want to write, when I call find example by name, assuming the DAO returns the right data back, that my business object does the right logic. So how do we do that? We're going to isolate those using mock objects. Mock objects have come a long way in the last couple of years. It used to be that you'd code a mock object that had you'd have a mock DAO that would just return data. Now we're going to use dynamic mock objects. So you don't actually have to code those, you can just use them. And by using that mock object and dependency injection, we're going to break these collaborator references, isolate this class under test, so that we know that assuming all those collaborators did their job right, the class under test will work right. So how do we change the factory to allow that? This is where we're going to that type 1 interface injection. We've included a map of overridden targets. We've added this method called override target. It puts a string, which is the target, which would be example DAO, and a mock, an ability to put an object, right, or anything you wanted to override in that map. That's going to store it in there. A check, is it overridden? Remove overridden targets. And then down here, this is the same code from before down here, but we've added this line here that said, hey, if you told me to override the target, then I'll return the one you told me to use if I get called. So I'll try and explain that in the demo here. So we're using Eclipse as our IDE. If you're doing Java development, extremely happy with Eclipse as an IDE. You can do a lot of other stuff with it too. On the screen. Okay, so here we have our example business object. See the find example by name method. This is the same code that I had in the PowerPoint earlier. It's going to call factory produce. It's going to ask the factory to find the example by name. It's going to do some checking and then return the DTO. Right? So how am I going to test that class? Right? I'm going to use a JUnit. If anybody's familiar with JUnit, JUnit's an automated testing framework. It allows you to create a class that tests the class. It's like writing a main. If you've written a main in any of your programs, you wrote a program that did something, you wrote a data structure that did something, you wrote a main to say, find out all this stuff and then check it. Does it work? Did it print the things I think it was going to print? This class is going to allow me to test my class. So for our developers, they're required to implement a JUnit test before they actually start coding the class, code the class, make sure the test tested it. They should know what that class does before they write it. So here, I'm using the Easy Mock framework. We have a mock control, an example DAO mock that's going to be returned in our setup for our JUnit. You can see we asked the mock control to create a control of an example DAO. We asked the mock control to return a version of the example DAO. We cast it back. We have an example DAO now. So in our test method down here, eventually we're going to say example business object equals new. We've got a new example business object. We're going to call find example by name and ask it for the hello world example. And then we're going to verify the results down here. So our mock object, we need to record the functionality on it before it knows how to behave. So we say, hey, mock, if you get called with find example by name and the parameters are hello world, return this fake object I made up here, which I said the name is hello world. Right? So I made a DTO, and then I stuck it in the mock and said, if you get called with this method and these parameters, return this object. I'm going to put my mock control in replay mode. I'm going to override the method on my factory. That way my factory now knows if anybody asks the factory while it's overridden, for example, DAO, to return that mock. Then we're going to actually run our test by calling find example by name on the example business object. Come down here and we're going to assert the return value here from the find by name. Its name is really hello world business object, which is what we changed it to from hello world. And then we're going to verify that things were called in the right order. That's part of the mocking framework. That the verify method says, hey, you told me to call these 15 different methods, and with these different parameters, did you really call me in that order? I'm talking like the micro machines guy now, but let's try and run this. So you can see here, I have a positive test and a negative test. I didn't talk about the negative test, but when we ran this hello world positive test, it did come back and it asserted that the string was now hello world business object. And you can see that we had one failure, which is my negative test. Just wanted to show you can have a failure without an exception. Normally you'd want to test for failure scenarios also in your test. And what it's saying is, in the failure, hey, you said you were going to call me with hello world, but over here, in my negative test, I called it with hello world. Right? So when you look back over here, you're saying, it's saying, the framework's saying, hey, you told me you were going to call me with hello world, but you said hello world. And so it fails that test. So that's how, but notice, we did call a business object, which was in turn calling a DAO. And we were able to tell it by using the factory type 1 dependency injection. We were able to tell that DAO not to go to the database. We would put a mock out there of it. And that enabled us to break those dependencies and test this one unit in isolation. I think that's all I have. Let's go back. I got some resources here. Oh, this is another way to do it. If anybody's interested in that, I can send that out. It's a way to have it without a framework. And then resources. Anybody has any questions?
Well done. Any questions?
Can you put the resources back up?
Sure.
I have a quick question. In addition to the patterns that you discussed here today, is there immediately after that another pattern you haven't discussed?
Today, we've really heavily used a session facade with a facade in our application that allows you to hide the inner workings. I mean, in an enterprise application, that pattern, I mean, I couldn't have a service layer without that facade. So being able to put my business objects inside of a business layer and wrap them with a facade and allow any of those container or aspects that happen when you cross boundaries, we can cross-cut on that facade and add things like logging. And that's a little bit of aspect-oriented programming, but that's one of the things that it's really allowed us to do is add that functionality in when you have a common entry point to those different layers.